Welcome to Operations Research, Decision Theory Lectures series by Professor Joyjeet Ghose. This is the first lecture of a 3-lecture series. This lecture will be on what is decision, introduction to decision theory, need or application of decision theory, classification of decision theory. He will also be discussing the decision-making under certainty, risk and uncertainty. The following decision criterion will be discussed: Criterion of Optimism / MAXIMAX Criterion, Criterion of Pessimism / MAXIMIN Criterion, Criterion of Regret / Savage Criterion, Equal Probability Criterion, HURWICZ Criterion, Criterion of Realism. Several examples on this has also been discussed. So, do not miss and watch the full video. For the next video in the lecture series, please click the suggested video link above. You may also click on the playlist at end of the video to access all the videos. Please subscribe this channel and yes, do not forget to like and share. Also click on the bell icon to receive instant information of new videos uploaded. Thank you.
Hello friends, welcome to this lecture on decision theory. This will be the first lecture of a 3-lecture series. In this lecture, we will be discussing about what is decision, what is decision theory, where to apply decision theory, what are decision making under certainty, what is decision making under uncertainty, what is decision making under risk, and we will be discussing problems based on decision making under certainty, decision making under uncertainty. We will discuss the various criteria of decision making under uncertainty. So let's start. So we'll start with very basic. What is decision? So decision is basically a conclusion. When I say decision, I essentially mean a business decision. Business decision is basically a conclusion of a process in which the decision maker or the manager weighs the alternatives that he has and based on certain criteria and comes to a conclusion that a particular alternatives is best suited for the interest of the company. So that is what we define as decision. So in terms of the decision, a decision is a conclusion of a process designed to weigh the relative utilities or merits of a set of available alternatives so that the most preferred course of action can be selected for implementation. Now, okay, but that's to understand what is decision. Now, how to take a decision? How do you evaluate the relative utilities or merits of the sets of available alternatives? Well, that is what we'll be dealing in decision theory. We'll understand how a decision maker will come to a conclusion based on the states of the nature and the alternatives that is available. Now, decision making can be under various circumstances depending on the degree of certainty as deterministic models. Sometimes everything is known to us, then we say decision making under certainty, and sometimes the states of nature are not known to us. Any state of nature can occur. Now, at this particular point of time, you may not know what is the state of nature. Don't worry. I'll explain what is the state of nature. So states of nature are not known, then we call it decision making under uncertainty. And in between decision making under certainty and decision making under uncertainty, we have decision making under risk. So decision making under risk is a probabilistic model where the states of nature are associated with a probability. In game theory, if you have studied, that is also a part of decision theory in a sense, but that is decision making under certainty but under competition. So here in this lecture series or in decision theory, all the decision payoff metrics that we'll be discussing will be individual payoff metrics, and it is not decision making under any kind of competition. Okay, so we should understand that and we should proceed. So we'll start with decision making under certainty. We'll do 1 or 2 examples of decision making under certainty, and we'll discuss decision making under risk, 1 problem or 2 problems. We'll discuss decision making under risk, and then we'll discuss decision making under uncertainty. The 5 criteria of decision making under uncertainty. And in my second lecture, we'll be discussing in depth decision making under risk. In the third lecture, I'll be discussing decision tree. So let's start with this lecture. So before we discuss this, we should understand few terms about the payoff matrix in decision theory. First, the alternatives. Alternatives are the options that a decision maker has, or typically it's the course of action a decision maker can take. So there can be a set of alternatives or set of course of actions. Those are called alternatives. And states of nature. States of nature are the things that happen which are not in control of the decision maker, or external factors which are not in control of the decision maker. These are called states of nature. Now, what are outcomes? A particular combination of a course of action or alternatives and the state of nature, the payoffs, is called the outcome, if that is known to us. So this is better understood by an example. Suppose I have to go out tomorrow and I have an option to take an umbrella with me or not to take an umbrella. Now my choices are, or the alternatives are, to take an umbrella and to not take an umbrella. Now if I go out tomorrow, then it may rain or it may not rain. Now the states of nature which is not in my control are that it may rain, it may not rain. Now if it rains and if I take umbrella, then I'll not wet my clothes. So that is an outcome. That is a payoff. And likewise, the matrix that we form is called a decision matrix or a payoff matrix for decision theory. So this is the payoff matrix for different combination of the states of nature and the alternatives. And typically, it's a practice that the alternatives are written in row wise and the states of nature are written column wise. It is not mandatory, but it is a practice. So with this, we move on with an example of decision making under certainty. So here everything is certain. I know if I take this, this will happen, and we are not bothered with the states of nature. So this is decision making under certainty. So there is a company called ABC Corporation. This ABC Corporation has invested in TV campaigns, and there are 5 TV campaigns that they have invested, and they know that for each of the campaigns what will be the expected sales increase. Now the question is which sales campaign they should use. So if you look at the problem, so if the company uses strategy A, that is the sales campaign A, that means the cost of that sales campaign is 1.8 lakhs and it increases the sales by 1.78 lakhs. So likewise, for each of the strategy it is given to us. Now the question is which strategy the company should follow. So if you look at this table deeply, it will be, you can solve this easily from common sense. You will find out the return on investment, and which is basically, this is the investment and this is the return. So return divided by investment is called return on investment. You find out this ratio, this divided by this, and whatever you get, you chart it out here, and whichever is the maximum will be the strategy that the company will select. So here, so utility or the payoffs, you call this utility or payoffs or return on investment in this particular case. So these are the values that came out, and for C it comes out to be the maximum 1.08. So the company will be selecting the strategy C. So for the next problem, it's a similar problem, but here there are 3 objectives of the company, that is to increase the profit and to increase the market share and to increase the sale, and each has a weight attached to it. Now company wants to attach its performance in terms of the market share, that is 50%. They are more interested in increasing their market share than they are interested in increasing their sales growth, that is around 30%, and 20% they want to profit. So these are their objectives. That is the objective of the company. And to achieve these objectives, they have three strategies. And the payoffs of combination of the strategy and these objectives are known to us for certainty, and these values are given. Now, which strategy the company should choose? Obviously, if you look at this problem from common sense, you can give an answer to this. So use a calculator, pause the video here and find out the answer. So the obvious answer would be, yes, you are right. So it should be this into this plus this into this plus this into this. You will find it out. Similarly, 3 into 0.2, 6 into 0.5, 7 into 0.7, all this composite utility you will find out, and like this, and it comes out to be, these are the values which comes out to be the composite utility or the weighted utility depending on the objective of the company XYZ. So it has been found that this is the maximum utility, and therefore the company should use the strategy 3. Okay, with this we move on to decision making under risk. Certainty means we know everything. In uncertainty, we don't know anything. Under risk, we know the probability of the states of nature. We know that this state of nature has this much probability attached to it. So that is decision making under risk. So in this particular problem, there is an insurance agent, and this insurance agent has these 4 strategies: S1, S2, S3, S4. And there are 3 states of nature that can occur. And the states of nature here, are 0.2, 0.5, 0.3. The probability attached to the states of nature. Now, these are the payoffs for particular combination of the strategy and the states of nature. Since there is a probability attached to it, this is called decision making under risk. We know the probability of the states of nature. In decision making under certainty, we know which states of nature will occur. And in decision making under uncertainty, we don't know the probability of the states of nature. Okay. So here we know the payoffs. Then what will be the strategy of the salesperson? Again, you can use your common sense and you can solve this problem very easily. Just like the composite utility, here you will find out the probability attached to it and multiply this by the payoffs. That is 0.2 into plus 0.2 into 4 plus 0.5 into 6 plus 0.3 into 10. We'll multiply the probability of each state of nature and find it out the expected value, expected monetary value. We call it EVM. We call it EVM, expected monetary value. Okay, so here, so for this 4 strategy, we found out this expected utility or expected payoffs. We also call it EVM, and or expected value of money, we call it. So here for strategy 3, it comes out to be maximum 0.8. So the sales agent should use the strategy 3. That means he should call up once and then follow it up with 2 more calls. So in this example 2, so there is a company for its sales target and strategies to achieve this target. The data in terms of the 3 sales targets, the respective utilities, various strategies and appropriate probability distribution are given in the table below. What is the optimal strategy? Very similar to what we have done in the previous problem. So these are the utility attached to us and the probability attached to us. So this is the target. So what strategy the company should use? Now there are 2 objectives here, the sales targets and the utility. So, and both may not match or both may match depending on the calculations that we'll be doing. So here, so we have calculated it. 50 into 0.6, 75 into 0.3, 100 into 0.1 gives us this. Likewise, for all of this we calculate here, and for the probability here we calculate this, and for the utility we calculate this, and luckily both matches for strategy 2. This is the maximum, this is the maximum. So strategy 2 is the optimal decision. It may happen that for this strategy 2 is maximum, and for this strategy 3 is maximum. This may happen. The two, because there are two objectives, the two objectives may be contradictory, but here it matches. So with this we move on to the third problem. So this is the third problem. In this, basically there is investor who has to invest in shares. This is regular share, risky share, and property. And these are the states of nature: low, medium, high. The market being low, market being medium, and market being high. Now, how many days the market is low, and how many days, or what is the probability of market being low, and what is the probability of market being medium, and what is the probability of market being high, is given to us in a sense. Here, for 300 days, it has been observed that 150 days are medium. That means 0.5% or 50% of the time it is medium, and 60 days market conditions are high. That means 20% it is high, and therefore if it is 50%, this is 20%, this is 30%. So 0.2, 0.3, 0.5 and 0.2, 0.3, 0.5 and 0.2, rest everything will be same. 3 into 0.7, 3 into 0.3 into 7, 0.5 into 10, and 0.2 into 15. So we'll find it out, and therefore the strategy 4, that is the invest in property, is the best strategy for the investor. Decision making under uncertainty. So here we don't know the probability of the states of nature occurring. So therefore what we do is that we use certain criteria, and one of the criteria is to use optimism, criteria of optimism, or MAXIMAX criteria. In MAXIMAX criteria, you can see here this particular problem will be taking to understand the 5 criteria. This is the first of the 5 criteria that we will be discussing for decision making under uncertainty. So it is uncertain, so we do not know the probability here of the states of nature, and these are the payoffs for this particular strategy and the combination of state of nature. Now under this criteria of MAXIMAX or criteria of optimism, we'll select the maximum of each strategy. So we are very optimistic, so we know we'll expect that this will happen here, and if we select this strategy, this state of nature will happen, and if we select this strategy, this will happen. So out of this we'll select the maximum. So based on this criteria, this is maximum of maximum is 26. So this strategy should be chosen by this principle. So here we'll select the first, the row max, and from the row max we'll select the maximum one. So this is the strategy that should be selected by this criteria of optimism. Next is criteria of pessimism. So here we are not very optimistic. This is also called wild criteria. So we'll select the best of the worst. So we'll select the worst one. So worst one means the minimum. This is the minimum of this strategy, this is the minimum of this strategy, and this is the minimum of this strategy. From this, the maximum is 12. So this strategy should be selected. So 12, 9, 4, and this strategy is selected. So this is the criteria of pessimism or MAXIMIN criteria. So maximum of the minimum. So next is the savage criteria or regret criteria. In this we create another table which is called an opportunity loss table or regret matrix. So for creating a regret matrix or opportunity loss matrix, we have to divide the payoffs for each state of nature by the maximum payoffs. Not divide, subtract the payoffs of a particular state of nature from the maximum. So 15 minus 15 is 0. So 15 minus 9 is 6. So 15 minus 13 is 2. Likewise, this is 14. 14 is the maximum one. So 14 minus 12 is 2. This is 0. This is 10. And this is maximum is 26. So this is 8. This is 16. This is 0. We create a table like this. This table is called regret matrix or opportunity loss table or opportunity loss matrix. So this is the opportunity loss matrix for this particular problem. So here we'll be selecting the maximum of each strategy. and from the maximum we'll select the minimum. So in a short it is minimax, a criteria of regret. So the first we'll select the maximum losses in each cases, and from the maximum losses we'll select the minimum loss. Okay, so this method is called criteria of regret. So with this we come to the fourth criteria, that is called equal probability criteria. In equal probability criteria, it is also called Bayes criteria or Laplace criteria. So here, whatever is the number of states of nature will give equal probability to it. We'll attach equal probability. So there are three states of nature. So it is 1 by 3, 1 by 4, or 1 by 3, 1 by 3, 1 by 3. So if it's 4 states of nature, it will have been 1 by 4, 1 by 4, 1 by 4, 1 by 4. Like that. And we'll multiply this into this, this into this. So plus this plus likewise, and find it out the expected monetary value or expected value of money, EVM or EMB, whatever you call it. So either is all the same. So here 15 is coming. So strategy 1 should be chosen based on equal probability criteria. So in HURWICZ criteria, we select an criteria of optimism. We select a value, a parameter, which is we call it alpha. So this is the parameter of optimism. This is a parameter of optimism. That value depends on how much optimistic you feel. So if you are feeling very optimistic, it will be closer to 1. If you are feeling less optimistic, it will be lower value towards the 0. So here what we do, we find out the p value from the rho maximum and the rho minimum. So we multiply alpha with the rho maximum and then multiply with the rho minimum, find out the addition of this. So here for this particular problem, so 18 is the maximum, 12 is the minimum. So I have taken 0.8. So 0.8 into 18 plus 0.2 into 12 will give us this. So from this strategy should be chosen. These are the 5 criteria which you can use for decision making under uncertainty. Let us solve a problem, then you will understand. So this particular problem, so these are the states of nature, and these are the strategies. So these are the payoffs. So for this particular payoff, use these 5 criteria and find out the decision based on pessimistic criteria, optimistic, equal probability, regret criteria, HURWICZ criteria. So all these 5 criteria you apply and find out for each of these criteria which decision the company should take. At this point, you pause the video here and solve it yourself, and I will show you the answer. So for this is the payoff matrix. So from this, the maximum is this one. Maximum of row 1. This is ABC, strategy A, strategy B, this is strategy C. So from this, maximum is 18,000, 20,000, 20,000. So from this 20,000, either of the 20,000 will be selected. So the company based on pessimistic, optimistic criteria can select either B or C. So the worst of this is minus 10, 0 and minus 2,000. So from this, the maximum is 0. So based on this pessimistic criteria, strategy B should be selected. Similarly, equal probability, there are 4 states of nature. So we'll multiply each of this by 1 by 4, that is 0.25, and then add each of this and we'll get this. So this is 4,000 into 0.25 plus minus 100 into 0.25 plus 6,000 into 0.25 plus 18,000 into 0.25 will give me this value. So we'll calculate this. The maximum will be my strategy. So according to equal probability, then this is the strategy you should follow. And for regret criteria, so this is the loss table or loss matrix. So this is the maximum. So maximum minus this is 0. So this is 0, 0, and this is 16,000. So this is maximum is 15,000. So 15,000 minus 15,000 is 0. So this is 10,000, and this is 15,500. This will be added because this is minus. Likewise, we create this table, and from this the maximums will be selected, and from the maximum the minimum will be selecting is this one. So based on these criteria, this will be the best option. And lastly, using HURWICZ criteria, alpha we have taken according to the question given. So the row maximum, this into alpha plus 1 minus alpha into this will give you this, and the maximum is this one. So based on this criteria, HURWICZ criteria, this should be selected. Okay, this is another problem. So in this problem, just go through this problem. Be very, very careful. There's a catch. Try to solve it yourself. Pausing this video. Now I'll tell you the catch here. The catch here is the alternatives are given in column wise, and these are the states of nature. So many students make a mistake. So therefore, this it converted into row wise and this into column wise. You can do it by like this also, but be careful which is your, you should be sure or certain which is your states of nature, because these are the states of nature and these are the alternatives. Once you know this about, and rest of the things are very simple. So these are the answers of the question. So I hope this is clear to you. If you have any doubt regarding whatever we have discussed here, please put it in the comment section, or you can directly email to me. And thank you for watching.